This is a recording of topic 14-6, solving quadratic equations by factoring, day 2. Our objective today is I can solve quadratic equations by factoring. Our bell work today is for you to set up each equation on your topic, set them equal to 0, and then find the sum and the product for each of the problems. You can pause at this point and do that, or you can go on to the next slide and we'll check your assignment from 14.5. The answers to 14.5 are here. If you need more time, pause the video. Before we start, we're going to be solving quadratic equations by factoring yet again. You will need to know what the 4 steps to solving those quadratic equations are. If you need to, refer to your notes on topic 14-5. They're listed there. I've also copied them into this PowerPoint, and so you're able to see them. Again, let me make my correction where it should say ax squared plus bx plus c. So in order to solve, our first step is to get our quadratic equations in standard form, meaning set it equal to 0. You also notice that sometimes our variables are other than x, but we can still use the same steps. So the first thing is we need to have our equation set equal to 0. And we like to have our squared variable to be the positive one. So if I look at number 1, I see I already have an s squared that's positive. And so I am going to move everything else to the side of the s squared. So to get 0 on the right-hand side, I need to move the 18s. So I'm going to subtract 18s from both sides, because what I do to one, I have to do to the other. That will make 18s plus, or sorry, a positive 18s minus 18s is going to be equal to 0. And I also need to move the negative 81, or you see minus 81, so I'm doing the opposite. This is plus 81, and what I do to one side, I must do to the other. So I have to put a plus 81 over there also. So again, on the right-hand side, this negative 81 plus a positive 81 equal to 0. So we now have our right-hand side equal to 0, and on the left-hand side, we have s squared minus 18s plus 81. Again, I want it in order, with my squared term followed by my term to the 1 power followed by the constant. Now let's go through factoring completely, because we've set it equal to 0. So the first step of factoring completely was the GCF. Look in front of the s squared. There's not a number, so therefore there is no GCF. Second thing we need to do is find our sum and our product. Our sum is going to be from the middle term, that's negative 18, and our product, I will multiply the coefficient of the s squared, which is 1, times 81 and get 81. Now we need the factors. What two numbers multiply to give you 81, but add to give you a negative 18? That is going to be negative 9 and negative 9. Negative 9 times negative 9 is a positive 81. Negative 9 plus negative 9 is a positive 81. Just to recall, I won't do this from this point on, but you could always use your calculator. In y1, you'll put your product, 81 divided by x. And in y2, you'll do 81 divided by x plus x. And then look at your table by hitting second and graph. X, y1, y2, y2, we had the plus sign, so that means I'm looking for the sum. So I'm looking for the number negative 18, because that's our sum. And then in x and y1, you will find negative 9 and negative 9. Those are the factors that multiply to give you a positive 81. Once we find the factors, the last thing to do is to rewrite it. There was no GCF, so we're going to get x minus 9 and an x minus 9. It's now equal to 0. We have rewritten our quadratic equation. It is now factored form. So now our next step is to set each one of the factors equal to 0. So let's start. X minus 9, I'm going to set equal to 0, and x minus 9. Notice I even changed to x's myself, and we are actually using the variable s. So s minus 9 equal to 0, and s minus 9 equal to 0. Go back and change these to s's. Notice that they are the same thing, so once I solve for one, I'm actually solving for both. I want the s by itself. I got to get rid of the minus 9. Opposite of minus is addition, so we will add 9 to both sides. That gives s by itself, and 0 plus 9 is 9. I will get the same thing on the other side, or for the other factor, we'll get s equals to 9. This is known as a double root or double solution. So I'm just going to write that x is equal to 9 or 9. We can go ahead and write them both. I could write it once since they are both, but I'm going to go ahead and write them twice. Problem number 2, let's start with set it equal to 0. Well, it's already set equal to 0. Next, we need to factor completely. So let's go through the rules of factoring. Does it have a GCF? Let's look in front of the x squared term. I have a 24. So 24, however, does not go into 8. So now I'll look at, well, now let's look at 8 because it is a smaller of the two. Can 8 go into 24? And sure enough, 8 can. So my GCF is going to be 8. It is the greatest common factor between 24 and 8. I could have done 2 because 2 goes into both of those, but then it's not the greatest common factor. 4 also is a factor of both 24 and 8, but it's not the greatest common factor. So 8 is our greatest common factor. When we factor it out, let's put the 8 over there. Let's also look, I only have 2 terms. We've had this before. And so I'll look at my variables. Both have an x. One has an x squared, the other has an x. So I take the smallest of the 2 as far as the exponent, and it's an x. So our GCF is actually 8x. When I factor it out, what I'm left with, 24 divided by 8, that gives us a 3. And then x squared divided by x, we are still left with an x. Minus 8 divided by 8 is 1, and then the x divided by x, they cancel out, so I'm just left with 1. Again, this is still equal to 0. So it turns out we have factored completely because this is our GCF. There's nothing else. I can't do a sum and product because this is not a squared term inside the parenthesis. So I have completely factored. We have 8x, 3x minus 1. It's rewritten in parentheses. So I've skipped all the way to step 4. Let me just say that again. Step 4 of the factoring, not step 4 of, of solving. So I won't even put that there. We have factored completely. Now we're going to set each factor equal to 0. So out front I have an 8x, set it equal to 0, and I have a 3x minus 1. We set that equal to 0. We need to solve for x. X is being multiplied by 8 in our first factor, so we're going to divide both sides by 8. That gives us x is equal to 0, because 0 divided by 8 is 0. Looking at our other factor, we want to get the x by itself, but it has a 3 in front of it. I'm going to box it. That tells me I need to get rid of the minus 1 first, so we will add 1 to both sides. We still have a 3x in the box. Negative 1 plus 1 is 0. We chose the right number. And then 0 plus 1 is 1. Divide both sides by 3. That gets the x by itself. And we get a 1/3 on the other side because 1 divided by 3 cannot be simplified. So our answer, in order for this to be a true statement, x must be either 0 or it can be 1/3. Problem number 3. We have a 156 equals a negative 2n squared minus 38n. Again, our goal is to get it in our standard equation where x squared is positive. The number in front of the x squared is positive. And so notice we have a negative 2n squared. That means I want to move everything to the left-hand side because I want this negative 2n to be a positive 2n. It could work the other way, but it sure is nice when we are dealing with a positive coefficient. So let's move it to the left. I take the opposite of this negative. That means I need a positive 2n squared. What I do to one side, I do to the other. So I'm going to add 2n squared. And then I have a negative 38n, so I'm going to do a positive 38n, or you can think of it, we subtracted 38n from in the original, so I'm going to add. It's opposite of subtraction. So add 38n. On my right-hand side, I got a negative 2n squared plus 2n squared. Yes, that equals 0. I did that correctly. I have a negative 38n plus a positive 38. That's going to be 0. So yes, I got my right-hand side to be equal to 0. My left-hand side, I need to rewrite it. Again, I want to do standard form, so my squared term is first. That'll be 2n squared, followed by my n, so 38n, followed by the constant that has no variable, 156. This is now equal to 0. So we've taken care of the first step, set n equal to 0. Second step is to factor completely. It's supposed to be a 2. Factor completely. There are 4 steps to factoring. Let's see. Does it have a GCF? I have a number in front of the n. It's a 2. Let's check our other numbers. 38 can be divided by 2, and 156 can be divided by 2. So 2 is a GCF. I'll look at my n's. Notice I don't have an n with the 156, so n is not part of the GCF. When I factor out the 2, what we have left over is n squared. 38 divided by 2, that's 19. Still have an n there. Plus 156 divided by 2 is 78. This is equal to 0 again. So we factored out the GCF. The second thing we need to do is find what is our sum and our product. Our sum is what's in front of the n, or the 19, the middle number. The product is multiply the 1 in front of the n squared times our last number, 78, and we get 78. Our third thing is we need our factors. I need what two numbers will multiply give you 78, but will add to give you 19. Those two numbers are going to be 6 and 13. You can use your calculator to check it out just to be sure. And so now I will rewrite a trinomial in factored form. So GCF comes first, then x plus 6 and x plus 13 equals to 0. So we've taken care of the factor completely. Third thing we need to do is set each factor equal to 0. So I got out front 2 is equal to 0, then x plus 6 equals to 0, and x plus 13 equal to 0. Well, 2 does not equal to 0. There's no x's there. There's nothing to solve. I'll scratch that out. Let's do x plus 6. We have to subtract 6 from both sides to get the x by itself. This is 0 minus 6, or x is equal to negative 6. X plus 13, we're going to do the opposite of plus 13, so we'll subtract 13 from both sides. We get the x by itself. 13 minus 13 is 0, and 0 minus 13 is a negative 13. So for this quadratic, I'm going to go back to using n's. My n has to be a negative 6, or it's a negative 13. So you will often see me rewriting my equations with x's. That is fine, as long as when I answer my question, I am actually giving the correct variable at that time. Number 4, we already have it set equal to 0, so our first step is done. That's awesome. Next thing we want to do is factor completely. So step 2, we're going to factor completely. See if we have a GCF. I see a 3 in front of the r squared. 3 does go into 12, so I know 3 is going to be one of them. I see r with the first term, but not the second term, so r is not part of it. 3 is going to factor out. Let's divide everything by 3. That leaves us with a r squared, and then 12 divided by 3 gives us a 4. That is equal to 0. Next, we're going to find our sum and our product. The sum, notice there is no r, meaning I don't have a r to the 1 power. I don't have a middle term, so my sum then is equal to 0 because it doesn't exist. My product is going to be what's in front of r squared, which is a 1, times my constant, a negative 4, so our product is equal to negative 4. We need to find the factors. What two numbers multiply to give you 4? Negative 4, but add to give you 0. Those factors are going to be 2 and 2. Last but not least, we need to rewrite it. We have our GCF. This time I'm going to use the correct variable. And in our factors was negative 2 and positive 2. Again, this is now equal to 0. We have factored completely. In order for this to be equal to 0, we take each factor and set it equal to 0. So we have 3 is equal to 0, that's out front. R minus 2 is equal to 0, and then R plus 2 is equal to 0. Well, 3 equal to 0, there's no r's there, there's nothing to solve, and 3 is not equal to 0, so we'll cross that out. Solving for r, we do the opposite of minus 2, so it's plus 2. That'll give us r equals 2. And then our other factor, we have r plus 2, so we do the opposite, subtract 2 from both sides. That gives us r equals a negative 2. So to make number 4 true statement, r is either 2 or it's negative 2. Our last one. We have the area of a rectangular room. It's given by the equation L squared minus 5L equals 66, where L is the length of the room. Now we want to find what is the length of the room. Again, it is a quadratic because I see a squared term there. So I say I need to get it set equal to 0. That means we want the right-hand side to be equal to 0, so we're going to subtract 66 from both sides. And subtracting 66 from both sides, our new equation is L squared minus 5L minus 66, and now that is equal to 0. So we did the first one. Second step, we need to factor completely. So 4 steps to factoring. GCF, there is none. There's not a number in front of the L squared. Second step, we need to find our sums and our product. So the sum comes from the middle term. That is a negative 5. And the product, multiply the coefficient in front and the last. That'll give us a negative 66. We need to find the factors that will multiply to give you negative 66, but add to give you a negative 5. That's going to be negative 11 and a positive 6. And last, we need to rewrite it in factored form. So with our parentheses, our variables L, we have L minus 11 and L plus 6. This is now equal to 0. We factored everything. Last thing we need to do, or the next thing we need to do, is set each factor equal to 0. So that gives us L minus 11 is equal to 0, or L plus 6 is equal to 0. The last, we need to solve for L. So we're going to add 11 to both sides to get the L by itself. That gives us L is equal to 0 plus 11 is 11. And then on the other factor, we subtract 6 from both sides, and it gives us L is equal to 0 minus 6 is a negative 6. This was a word problem. We need to answer the question. The length of the room is, now we have 2 possibilities. It's either 11 or it's negative 6. Remember, can we have a negative length of a room? The answer is no, so we cross that out. The length of the room is 11. Again, we cannot have a negative length. How would you measure a negative length? So if you were in class, we'd do this little closure, but since you're not in class, that will conclude topic 14-6.